Hello everyone, welcome to Stingray Speedway. A while back I had an issue with the track relay board where the current running through the relay, it had a high resistance closure on one of the relays for the red lane, and the car wasn't as fast. So I got that fixed up, ordered another relay board and some extra relays, replaced the relay board and the bad relay and the spare relay board, got it fixed up. But I didn't have a real good method of testing. So what I did was I came up with this method. This is a 1156 taillight bulb, single center connection with the brass housing around the bulb. Old school taillight bulb. The washers are on there for weight, but what this does is it takes standard slot car guide braid up through the 3D printed piece along with the flag to hold it so it doesn't spin around and short out on the track. And it goes up inside, makes contact with the bulb base and the center contact. And this bulb is 2.1 amps according to the specs, and it's around 21 watts with at 12 volts, which is what we run on the track for power. And the way this works is you can take and put it on a red lane, set it on there, and I can take my hand and get out of the way, my DD302 DeValco controller, and if you pull the trigger, you can see the light lights up. That was just a short pull. Now, if I come down here, these particular power supplies have pretty darn accurate amp meters, which is the second row down on this meter under the 12 volts. So if I pull this, you'll see the current. The bottom row is wattage, but you'll see the current. And as a light bulb heats up the filament, it increases the resistance, and therefore the current will drop as the light bulb stays on. So if I turn it on, and you can see how it drops down. So if I pull it, you'll see that it's almost up to 2.1 amps. It is for a moment, and then it drops down. So this red lane track draws around 2.035 kind of on average, and that's the DD302 DeValco controller. But if you look at the other controller, it's 1.998 amps for a DeValco DD300. So if I put this down here on the white lane, which has the DD300, and I get down underneath, you'll see that this one, pull the trigger, is a little less, 1.996 on average. So if I pull it again, full throttle, 1.9956. Filament's heating up. This is a DD302, or sorry, 300. And that is what I came up with to consistently test all of the lanes. They're all essentially the same except these controllers. This controller draws a little bit, allows a little bit more current to pass through as opposed to the DD300s. Could be the resistor network in them. This one is 3D printed, and as long as you don't keep it on for a long period of time, it won't soften the plastic, which is PLA, and it works out great. And I can take this and I can put it over here. There's a tap over here and another tap over here, and then when it comes around this way, this side of the track has a tap right in here, I think, and then all the way around through here, all the way over to here is the end tap. So this entire loop and lead on from there to down here, there's no taps in this spot. So I can take this and I can put it any place I want to on the track and move it around and check for power tap, current flow, and different things. And now I can actually check to see if the track has any issues, whether or not the tracks are even, which they are for each lane. And then basically for checking power, for voltage, I made these. This is a small little voltage meter, and these are quite accurate as well too. And this goes on the track over here, and I'll show you this. I might have to hold this down. We'll see if it works just sitting on the track by itself. But this is for testing voltage. Nope. I'll have to hold it down and pull the trigger. Okay. "12 volts. This thing is within a hundredth of a volt normally. So if I come over here and put it on the white lane, see what it does. I'm not going to push it down. 11.9. It's probably 11.99, because if I take the if I take the power supply and kick it up to 12.01, this will change to 12.0. So that works out really well. I made a bunch of these and gave them away as some presents and a few things, but it works out nice. It's just a small little device, and the two stainless steel screws make contact with the braids. So this works out pretty nice. I like these. And you can take this around and check your voltage taps and voltage on the track in different sections and see how it works. So with those two devices, I can check the entire track for good power connections. And so that's what I ended up working on, was the one for doing current test draw under load, and seems to work just fine for me. So I just wanted to put that out there for you guys to take a look at. If you're in need of the same thing, you can come across using a voltmeter, just a DVM meter for this across the track braid. And for this, you can put the voltmeter in line with your power supply for each track lane, and then make sure that the track is getting the same amount of current, but you need some kind of a load to pull current through each of the lanes. But I wouldn't use a car. The cars are basically not going to be pretty much the same track to track. The motors are going to have a little bit of variation, but the bulb seems to work well. You probably could use a car with a motor if you wanted to. It probably would be just fine, but the bulb is always going to be quite consistent. And the two parts here work out really well, and they were quite inexpensive to make. So just to let you know, check your tracks and make sure you have the same power and current availability on all the lanes. Thanks for watching. So long.